Hi, everybody. This is Mark Schaefer with iNEMI. So thank you all for joining. I appreciate everybody's time today. We have a very exciting schedule and speakers. This is the Tech Topic series for eco-design for circular electronic economy. This is our second session, and our speakers are from Schneider Electric and Fairphone. So first off, I want to thank both of them for joining us and being part of this. I think it's going to be a very interesting session. But with that, I'm going to turn it over to our moderator today, Julio Vargas. Julio.
Thank you, Mark. As you said, we have three speakers today. We're going to start off with Christophe Garnier from Schneider Electric. He is the Global Environmental Standards Manager. Christophe has more than 10 years experience in Schneider Electric's environmental department and is an expert in environmental life cycle assessment and eco-design of products. Perfect fit for this presentation. So Christophe, I'm going to hand it over to you and Mark.
Thank you. Hello, everybody. As mentioned, I am part of Schneider Electric. In Schneider, my role is to follow the environmental standardization for the group. So I'm active in international committee at European and international level. And I am working in this environmental domain for more than 10 years. Next slide. I say to move. Okay, perfect. This presentation is done with also Gaurav, who is the director of circular business model in China. He's not with me today, but he's part of this presentation. Schneider, for those who do not know us, we are a global company. We are present everywhere, and we are developing all the electrical equipment from the electricity plant to your plug in your house, ensuring safety and continuity of services with software on top of that. And we are serving various types of industries. So we are in the electrical world. Next. You know this chart. We split in two, and in red, it's what we are currently doing. So you can see on the left what we call in Schneider the enablers of circular economy. That's the downstream. And on the right is the execution of circular economy, how we implement it in the company with all the services. You know that the loops I'm showing how we can put back material or equipment into the process. So the inner the loop is, the better it is. Next slide, so we can see some examples and of what we are doing. Announced to use to double the recycled plastic we have today. We have a program called Green Premium, which is an eco-design process allowing to show information to our customer, basic information on what is compliance, to ensure compliance, and also what we do beyond compliance. We have developed a policy for our sites in the world. Packaging, we are doing a lot of things now for packaging and trying to implement circular innovation at each places. Next. And the downstream, that's some numbers. I won't spend too much time on that. We are now promoting a circular label certified, which is on top of Green Premium for products with a special treatment we have in the company. So because they are recycled or because we reuse part or things like that. So some of the concrete example, upstream. So what we do in our product. This is the typical Schneider product. It's called a circuit breaker. That's something you use in, you have small one in your house, but you have bigger ones in industries and very big one in very big industries. And that's the heart of the Schneider business. For instance, this product, we are working a lot on resource efficiency because this is plugged all the time. So this is a key aspect. And we have a lot of work on that. But after energy, we are now moving to resource efficiency. We are avoiding, of course, all the regulatory substances, but we are also trying to remove substances like halogen and so on, which are not necessarily regulated to go beyond what regulation. And bring more benefit to our customers. We used upgradability and durability. Durability is the heart of the company. We need to develop products that are developed, yes, to work 10, 20, 30, 40 years. So this is in the DNA of the company. So nothing really new for us when you talk of durability. But upgradability is pretty new. So you will see other examples later on to show how we are now able to change just some pieces of the product and not the whole product. The Green Premium has an important support for that. That's what we call Product Environmental Profile. It's better known as EPD for Environmental Product Datasheet, which is the generic word name. This is a document where we provide information on the composition of our product and the environmental impact of our product. It goes from substances to material composition and down to life cycle assessment. You see small numbers on the right. This is the life. The columns are the life of the product. So from manufacturing, production, raw material extraction, production, and transportation, use, and end of life. And for each of the life cycle stage, you have the environmental impact on water, ozone depletion, and so on. The traditional life cycle assessment. That's type of document we provide for now. Above 80% of our product turnover are covered by UPEP. And this document is developed according to the 14025 standard, which means the data of this product is third-party certified. So it is Schneider number, but they are checked by an external company. And we are working with, as you can see on the bottom left of the page, the first page of this document, with an organization called PECO Passport, which has a program where we can certify this document. I have more to say on that. Maybe we can have Q&A on that. And there are some links with US I'd like to mention. Next. For instance, a zoom on the CO2 footprint of our product. So when you have this document, you know the CO2. Next, I think there is another thing displayed on this page. No, okay. So the CO2 displays the impact, the carbon footprint during manufacturing, use, and so on. So a user can have an idea of the impact of the product they buy and the product that will be the carbon footprint that will be generated during the use of the product. Next. Another part of the information we provide to our customer is what we call circularity profile, used to be called end-of-life instruction, is what to do of the product at end of life. So how to dismantle it, where are the key parts. If there are, let's say, safety parts, like springs that can pop up or jumps, or material or critical raw material, or fluorinated gases, in some cases, they are mentioned, and you know how to access them and to remove them. So a recycler getting our product can know what to do and what is important to check at end of life. All this information is available for free through different means. We have a web application called Check a Product. Basically, the customer enters the serial number of the product, and then he or she gets the information, substance information. So, for instance, REACH or ROS or Prop 65 compliance of the product. So this is freely available to customers, and they can have this type of information, plus the product environmental profile you saw at the previous page. We have similar access to the phone app, and also the online catalog has also a link to this information, so a specific environmental section that you can reach from the online catalog. So a very big push to bring this information and make it available to our customers. Downstream examples. So now extending end of life. What we call modernization is that we are now developing products with a communication part. So we can know where our products, where are they used, how they are used, and that can help better understanding of the life stage of the product. A circuit breaker if it is used a lot of time, then some pieces, key pieces, may be more used than others. So we need, this is very important, to optimize maintenance, not to do too much, but not to do too less. And we have now possibilities to add these communication layers to existing products so that we optimize the life cycle, the full life of the product by adding this layer. What is called refurbishment here is more, I wouldn't call it refurbishment, but it's how it is mentioned here. It's to replace a piece of an equipment without changing the whole equipment. And in that case, it's a battery pack. So you just replace the battery and not the full equipment, and then with an easy pack that you can just plug and play to replace it. And the next one is end of life collection and recycling. We have special components, and one is the SF6 gas, and this is collected by our engineers and field technician. So the product are cleanly dismantled, the gas is extracted from the product, and the certificate is sent to the user. So that's type of things we are already doing, and we have ideas to go further. So the first one is basically managed by product environmental profile, and the second one is covered by end of life. Next. This is an example of what we call retrofit. This is a big circuit breaker, and there is a case with metal, with drawers and things like that. When we know it's time for changing to ensure continuity of function, we just replace the inside part, and by doing that, you can see that the save we can do, but a retrofit solution means just changing one piece instead of changing the complete equipment. So you have numbers below to calculate, and thanks to the PEP, we can calculate this type of information to know what we save. And customers are very happy also to have this type of information so that they can incorporate it into their CSE report and things like that. Next.
Christophe,
yes.
Just a friendly reminder, we are at 14 minutes, so five
okay.
more minutes so we can have some Q&A.
Okay.
Thank you.
Good. The type of benefit we can have by closing the loop, as we can say. So we have sensors that we add now that improve the life cycle by checking humidity and hard condition, I would say. So you see the number of tons of metal and CO2 we can save by doing this type of retrofit. As a summary, what we can provide to the customers that can provide benchmark with other products following the same rules. I mean, we can compare with this type of information between an existing product and a new one. So we can see the benefit of having new products. We can work not only on the product, but on a full system. So we can also measure the impact, the benefit that a new product can bring on a global solution. By improving one element, we can improve the global solution. At the eco-design stage, we can see what is greener with life cycle assessments. For instance, is it better for the bars we have in the product? Is it better aluminum or copper? Or I don't know, for pallets, is it better wood or plastic? With the tools and the process we have, we can check that. Refurbished versus new product, it's kind of obvious. And reducing CO2 emission, because we can count, we can know if we reduce and how much. And we have in our process what we call green claims. So that's when we design a process according to our green premium process, the teams developing need to show that there is at least 1 or 2 or 3 points that they will improve drastically and go beyond the regulation. Next. Our customer, of course, they get an improvement on the total cost of energy in most of the time. And what we are mentioning, what we are seeing now, and that's pretty interesting, that some customers or resellers are telling us that they would be already agree to pay same for a second-hand product or even more for a new product with clear environmental benefits. So we are now trying to see that the green aspect of a product can become a key decision aspect into the decision process. And that's make me pretty optimistic when you see that it's not only cost now, the green aspect is also very important. So we are saving resources for the world, improving some jobs. I think we need to develop more the process and the circular economy business model around, but it's in progress. We have plans for that. And the relationship with our customer is improving also, because we just not talk about cost, we are also talking about longer life management with improvement, durability, maintenance, and so on. So we establish different types of relation, and also talking of environment brings another type of relation with our customers. So thanks for your attention. I hope you were. And we have a Q&A session now, so ready for questions. Thanks.
Thank you very much, Kristoff. Very interesting presentation. The first question we wanted to address was, how did Schneider initiate or start looking at circularity, and where did you start?
Before circularity, before we use this word, let's say a couple of years now that we're using this, we were really involved into the environmental field, the more general environmental topic. So making product durable, making product repairable, it's in the DNA of the company due to the type of product we are selling. And we quickly, Green Premium is 15 years old, something like that. So since that time, we were already engaged to go further than what regulation forced us to do. So this is a long story for Schneider, and circular economy is now really getting in action, and I can feel that in many areas of the company. We have small initiatives, we have larger scales initiative, and there is really something going on now.
Great, thank you. Another question we have is, you mentioned a lot of innovations, sensors being implemented, and that as part of the product, and also tools that you're using, the product environmental passport. How has this provided feedback and influenced the design phase of your product, or do you have plans to use the feedback from these tools in order to influence design?
Yes, sure. For instance, when you have feedback on product installed for 20 years or 30 years somewhere, if you just sell your product, you don't know how the product is used. When you have a communication, and it can be a very simple communication, just send one bit of information to say it's on, it's off. You have a better understanding on how the product is used, how the product is aging, what are the key components that are suffering from age or use, and that has an impact on the design phase. Let's say, for instance, the repair process. If we know that some pieces are more subject to be replaced, these pieces will be, I don't know, put in front of the product, or in an easy place to replace, or put together. So there is an influence due to communication on the design phase. And one word I'd like to add also on this PEP, so product environmental profile we call. This association, PEP Eco Passport, is a French association, but with international recognition. So it's following the ISO 14025 environmental communication standard on third party. And this association is also has an agreement with the UL department, and it's called UN Environment. And UL Environment developed similar documents. So they don't have exactly the same name, but they have a database called SPOT, UL SPOT. And this database also contains equivalent of PEP, so the one managed by the French PEPECO Passport organization, and there is a compliance between both. So a document developed in Europe in PEPECO Passport is recognized by UL in the US and vice versa. So it's to show that it's something not easy to implement, but we are now starting to have international recognition because it's a very strong process and very, I would say, reliable communication system.
Great. We have several good questions, so I'm going to try and combine a couple of them. Here's one from Mike Kirshner. To what extent are customers actually accessing and using this information for anything other than environmental regulatory compliance, meaning the information that you provide, that you showed in one of the slides? And
maybe you can, that was the question, or you have another part for the question?
And how has the feedback from the customers influenced design?
Yeah. So the answer to the first part of the question is the slide I presented with the what we call check a product. Yes. Next. Yes. So check a product. It's on the website for getting the PEP and the substance information. So you can download, generate automatically a ROS certificate or a REACH certificate from the website. So you type your serial number and you get a PDF signed by Schneider telling you that your product is ROS or REACH compliant. So there is an automatic process to provide you this certificate. It's generated per request. The app on the web is also providing information. I'm not sure it's providing so much information, but also information. And there is a special link from the online catalog linking to this environmental information with the PEP. And this type of information can be also found from the reseller website where our products are sold. And for the second part of the question, the feedback from customers is going beyond regulation. Of course, they want to ensure compliance, and that's what pushed us to make it very easily available. But the other question is beyond. So how can I demonstrate that your product is going to save CO2, or what will be the CO2 footprint of your product? Do you have such substance in the product? And this type of question and request we had pushed us to move in this direction.
Great. And you mentioned life cycle assessments and comparing different decisions that could be made at the design phase. What were the biggest surprises that you learned from performing the life cycle assessments, and how did that feed back into your design?
The first, which is not a surprise, is it's not an easy job. Making a life cycle assessment of a product is really a tough job, requesting a lot of resources, a lot of expertise, a lot of data, especially when you see the product I presented with hundreds, not to say thousands of pieces. So this is a very demanding job. The surprises, I'm not sure we got so many surprises. It helped us to take decisions, but there were not really big surprises. Sometimes it's understandable that the impact of wood is different from the impact of a pallet, so we can measure and have a better understanding. But I wouldn't say there were big surprises.
Anything that you would do over, repeat, or stay away from in design?
What we are now working on is trying to really move from linear to a circular. So it's really to try to close the loops. And that can be done by the design of our product. So to make it more repairable, more, which is, we are above average for that. But let's say to have more parts that can be reused, to have, so the product itself, but also to close the loop by new product models. And one of the big difficulties, and I guess we are not the same, is to collect products at end of life to close the loop. So get the product back from the customers. And we have customers everywhere in many locations, many types of plants and so on. So collecting this equipment to have a minimum amount that we can work on to develop this new circular economy business. So that's really what we are aiming to do. We have some small scale business we are trying to look at, some prototypes, I would say. I can't tell you for the moment, but maybe if I'm invited later on, I can tell you about. And we will see what it represents as logistic and the minimum volume we need to have. So we are working in this direction. So mistakes to avoid, I don't think so. But making products more circular for sure. But now working on the big next step is closing the loop with business models to move product and to have not only look at the product itself, but at the way the product is living, where it goes, how we get it back, what we do with it, and so on.
Wonderful, Kristoff. Thank you very much. We do have a lot of questions coming in the Q&A and also in the chat. And what we'll do is we'll try to collect these questions as if we see if we can address them in the future. But we're right on time, and I think that we're going to move over and introduce our two presenters from Fairphone for the day. The first presenter is Thea Kleinmagd. Thea is part of the Impact Innovation team and focuses on fostering fair circularity and decreasing the environmental footprint of the life cycle of mobile phones, with the goal to change the industry from the inside out, as well as Miquel Ballester, who is the product management lead and has been part of the founding team at Fairphone, a smartphone brand that produced the first modular and ethical smartphone. So with that, Thea, I hand it over to you.
Yes, thank you very much. My colleague Miguel and I will today talk you through how Fairphone's approach of a modular phone enables circularity, and that also on various levels. So on the next slide, I'll first give you a very short introduction of Fairphone, since probably not everyone in this call is familiar with our company. So in 2010, Fairphone started as an awareness campaign against conflict minerals, and that also focused on consumer electronics. And back then, we noticed that although people were really willing to use a fairer alternative, there was not really one on the market. And we felt that we have to be part of the system if we want to change the system from the inside out. And this marked the birth of Fairphone as a social enterprise. And then in 2013, the Fairphone 1 has been released. Right now, we have released 3 models, but you have to note that the Fairphone 3 Plus is sort of the same model than Fairphone 3, but we upgraded modules, so that's one of the reasons why people replace the phones. The camera is up to date. So on the next slide, a short look at our mission, because we want to raise awareness of the story behind the mobile phones that we use, and then also uncover the complex supply chains behind it and behind all the electronic products. And therefore, our mission is to set an example first to the tech industry, and then showing the industry that it's possible to produce electronics more ethically than we do it today, and that also at the same time commercially successfully, because thereby we want to motivate the whole industry to also be more sustainable and be a driver for change. And on the next slide, you can see our impact areas, because the question is, how do we get there and how can a fairer phone be made? And we are sure, or we show that we can make a difference, and how for example, fairer materials are sourced, and also the working conditions in the production, or also the way the phone is designed. And also we aim at enabling its reuse and its recycling. Yes, so now you will see on the next slide our agenda for the rest of his presentations. So you might think that smartphones are quite small, and that might evoke the perception that they are not that relevant for sustainability. But I'll give you a quick overview on the context here, on the environmental impact, before Miquel then takes over on the design part. And afterwards, we'll shortly show you how Fairphone's approach enabled circularity. So the next slide, please. Yeah, so you can here see that the share of the ICT related emissions is projected to increase, and that quite a lot. If you look at the exponential fit here in this graph. So by 2040, we would then be with the whole ICT emissions by around 14% of the global environmental footprint. And when we look at the chart at the right, the blue part indicates how the share of smartphones developed from 2010 to 2020. And we can see that it has increased 7%, and we are now at 11% of the ICT emissions, which is, in my eyes, really remarkable. And yes, the reason for this we can see on the next slide. Because we produce a huge amount of phone every single year, and due to this short lifespan of just 2 to 3 years, they become e-waste very quickly. And we also know that only 1/5 is recycled, and thereby we lose access to many valuable materials. And if the phones are not properly recycled, we also cause health and environmental hazards, and also especially if the phones are exported as e-waste in countries that have not a recycling system in place, as we do have in Europe. So, and that leads to how we can see on the next slide. Also, that we have to look into the emissions from our phone, or the whole environmental impact that it has throughout its life cycle. And we assess the impact of our phones by conducting LCA on each of the different types. And we can see here that in all the 5 impact categories, the production is the main driver of impact. And therefore we can draw the conclusion that prolonging the lifespan is essential to decrease the environmental impact. And so we found out if we extend the lifespan to 5 or 7 years, we could even decrease the impact on global warming here in the second graph to 29 or by 42%. And of course, the longer the lifespan, the less phones we need. So we also reduce the e-waste with this a lot. And then on the next slide, I will hand over to Miquel.
Thank you, Thea. We can move on to the next slide. So you are in the room, of course, you've heard many times about circular economy, so I won't talk too much about it, of course. But I really like this graph that we have, like the one that is on the shape of a pyramid. This comes from Circular Economy consultancy here in Amsterdam. I like this way of depicting it because it really shows how by having the supply chain, you are adding value to these materials, to these components that eventually become a product. And then there's a use phase where these products are at the highest of their value, and then it starts decreasing unless we have the right strategies to bring that value up. So at Fairphone, we say, hey, closing the loop is important, but we also need to slow this loop, right? Like you've probably heard it, but some companies tend to forget about this slowing the loop. And luckily the previous panelists were also talking about longevity and quality. And that's something that is very, very important in the circular economy, not only thinking on how to close the loop, but how to increase the longevity of the devices that we put into the market. Next slide. So what are some of these limitations? Specifically, we are talking now about smartphones and to a certain extent to other definitely other consumer electronics, but also to bigger electronics. There's an intrinsic limited durability of standardized components, especially for smartphones. Components that have been now over the years where smartphones didn't, the average lifespan of smartphones were around 2 years to 2 to 3 years. What we see is that now going into suppliers and asking for components that actually last longer, sometimes that's a difficult one. So the availability of these components is limited. Battery still remains an issue. We have already batteries in the market, for example, that can sustain around 1,000 cycles. So that's not so weird anymore, but still limited. So if you think of it, 1,000 cycles may take you over 3 years, more or less, until you have to change battery. And so that battery is replaceable is very important, but I'll talk more about that later. Software, super important, specifically, I would say like the software that comes with the chipset, which for those in the room that maybe don't know so much about smartphones, the chipset, we could say is the heart of the brain of the device. Everything else is designed around this chipset. When the software support of this chipset drops, because of course the chipset manufacturer may have their own product portfolio and make their own considerations as well, it is increasingly difficult to keep that software support for the device that is based on that chipset. At Fairphone, we have a long experience on that, and I'll talk more about that later, of like going around this lack of support and making sure that we can still provide our customers with security updates. Of course, promotion of phone replacements for newest technology. I have a feeling that this is slowing down a little bit in the market, but with the upcoming of 5G, we have again an excuse to buy new devices. So this is definitely something that is playing a role. Repair options, so that's also very important. So the very often availability of spare parts to repair a display or a battery are not, often not available, or when they are available, they are very expensive. And the last but not least, of course, user behavior. And that's, I would say, the most difficult to change, but the one where companies can take like really a brave role and really through marketing also convince their customers to do and use their products differently and longer. And next slide. So our approach to long-lasting design. So all our phones, even from the very beginning, Fairphone 1, so our first modular device was Fairphone 2, but already from Fairphone 1, we were offering all spare parts on our website. So that availability of repair is very important. So using standardized tools, making sure that the spare parts are available, but also providing the information for making that repair is very important. And the second one that you have here is upgrades. That's also something that we've been doing since Fairphone 2 for a particular part of the device, which I will talk about in the next slide. Reliability is very important. So design for durability and for quality is super important. We are a relatively young company, so there's still learnings to be done here, but we have been increasingly improving in there as well. So that's also very important. Easy to diagnose and to update. That sounds maybe obvious, but if you have an issue, but you don't have a way to understand what is the cause of this issue or what is the part of your device that you need to change to solve this issue, then that might also become a problem. So that easy to diagnose either with automatic tools, but also often through, in our case, our customer support, it is super important. And as I was saying in the previous slide, the fact that spare parts are affordable, as well as that are easy to take back, both for parts and complete phones. Next slide, please. So, and you may wonder, how does this all work? And I will speed up a little bit. So our phones are, since Fairphone 2 and Fairphone 3, our phones are made of modules. And basically what these modules contain are mostly the electromechanical components. So those components that may break sooner than others, depending on the use that you make of the device, or parts of the phone like the battery that have a clear kind of wear and tear process there. So batteries, it's all chemistry inside. After 2-3 years, sometimes 4 years, they are done and you need to buy a new one. So each of these modules, I could go through all of them, but as you can see, in our design, what we prioritize are parts that break more often, or that for sure at some point customers will need to change, like the battery. So replaceable battery used to be the most normal thing in the world. We are still thinking that you need to have a battery that's very easy to replace. The display as well, for example. So the display, you just need to unscrew some screws and you can remove it and you can have a new display in case it's broken. And then you have some smaller modules there that contain, so for example, the cameras or the front camera or some of the speakers or the charging port, for example, which is a very important electromechanical component that has to survive the forces of the charger. Next slide, please. So as I was saying before, one of the things that we have done to enable this longer lifespan is as you have here on the right, these are our cameras. So this is our main camera and what we call the top module, which also contains the front camera. And for Fairphone 2 and already for Fairphone 3, these modules were upgraded halfway the life cycle of the product. So that meant that for somebody that had a Fairphone 3, they could just simply buy the new cameras and they would just be compatible with the device that they have. And that's why Thea was explaining in the beginning, we have Fairphone 3 and Fairphone 3 Plus, but actually the main difference of Fairphone 3 Plus are these upgraded modules. So actually you could kind of make your own 3 Plus if you had your 3 just by buying 2 modules. And one important note to make here is that, of course, and we will see it in some slides later, that the footprint of these modules is much lower than the whole footprint of the whole device. So just that upgrading some of these devices is much better for the environmental footprint of the life cycle. Next slide. Yeah, so what you have here is, because you may wonder like, hey, this modularity comes at an expense, right? Like there are more housings, there are more connectors, there are maybe more PCBs even. But actually what we have, well, with the help of our friends at Fraunhofer, of course, because they did our lifecycle assessment, and I believe they are also in the room. So thanks for all the work. But one thing that we have investigated, for example, in the graph here you have on the left, is the difference between, so like the environmental gain that we have with changing a module and repairing this module. So if we repair that module and we use that module for repair, the environmental footprint comes down, immediately, of course. And what you have on the right-hand side are the components of that, what we could call that modularity overhead, which is much lower than you would expect. So around 2.3% of the CO2 emissions at production are caused by these, let's say, modular parts, so extra parts that you need to put there to make a phone modular. By having these 2.3% extra CO2 emissions, we are able to provide a device that is much easier to repair and hopefully, and we are seeing that in the market, much long lasting. I believe that was my last, and I'm going to hand over back to Thea. Thanks.
Thea, just a friendly reminder, we're at 46 past the hour, so 5 more minutes so we get a good Q&A session going.
Yes, I'll keep it short. And so we can directly move to the next slide, because now I'll explain you a little bit about how this actually contributes to indeed then afterwards closing the loop. And now we move on to retaining the value of the product on the market. So after that, we encouraged the first user to keep the phone for as long as possible. We aim for give the phone first another life. And if that's not possible anymore, then step by step, we have to move further to the outer cycle of this butterfly diagram that you can see here. So then on the next slide, you can see what our ecosystem looks like around our phone. So that means that so we have an active take back program where we incentivize users to hand in their phones, and these phones either are checked for reuse, so they are either reused, or if it's Fairphones, we will harvest the modules. If these ones are functional, they directly go into the stack for spare parts. If they are not, they will be checked if they can be repaired. If not, they go to recycling. And then, of course, also we support with repairs from the phones that users or current users hand in. And then there we come to the stack of spare parts, where the also repaired modules or the still functioning modules are part of. So with these modules, we can repair the phone again. And so we also have a module take back, meaning that when you upgraded your Fairphone 3 to a Fairphone 3 Plus, and you have suddenly 2 modules left over because you don't need your Fairphone 3 modules anymore because these ones are, let's say, the outdated ones, then you directly also get an envelope with it so that you can hand them back in, and we can also reuse them again in case that we, for example, repair a Fairphone 3 later on. Then on the next slide, we can see that also on the very last step, the recycling modularity can play a role. So theoretically, you can supply these different modules to different recycling streams, and with that maximize the outcome. So, or you can target the materials that you really want to recover from there. Practically, of course, currently nobody does dismantle a phone to the point that that you have the different modules. But when the system develops, we hope that with that the recovery rates can go up, or that we can recycle the materials that we want to recycle. And now on the next slide, we can see that we conducted recycling studies. So how can we improve on recycling, and what actually can we get back from our phones using different recycling routes? And here you can see that we managed to improve also our Fairphone 2. We were still, let's say, category D in this recycling index. And with Fairphone 3, we managed that we actually could increase the recycling rate of the phone that we have. So we are now at between 50 to 60%, including metals and plastics. On the next slide, we come to an end. And I will quickly summarize again what modularity actually enables closing the loops of the smartphone, because we can prolong the lifespans. So we can keep it in use for way longer than if we cannot repair them, because they are just components that have a limited lifetime. And if they are broke, you either repair them or you cannot use your phone anymore. And we can also refurbish the different parts way easier and take them back and reuse them in spare parts for other phones where they just fit in. And yeah, we can also more efficiently recycle if the system also adapts there, or we can target the materials that we actually want to recycle. And yes, that was it from our side. Thank you very much.
Wonderful, very interesting presentation. Thank you for sharing. So our first question has to do around partnerships. And Miquel, you mentioned component suppliers. How has your design influenced the relationship with component suppliers? And do you have any lessons learned there to share with industry?
Yeah, sometimes I would say sometimes it's surprising what can be done if you just ask for it. So sometimes things seem to be not possible, but it's just because nobody's asking for them. So that's so I would say feel free to ask, and then might be that it's not possible. But we encounter, for example, on the use of recycled plastics, which we are using in Fairphone 3, and we have some developments on the pipeline. We realized that it was, I would not say easy, but simpler than we thought, to get to higher recycled plastic percentages on our devices. So that was one, and others I would say That's a good question. So, for example, connectors for us are very important as well, and over the because of the modulars, obviously, and we've learned a lot about connectors and what works and what doesn't work. From Fairphone 2 to Fairphone 3, there has been quite some changes, and that has also been together with the suppliers, obviously. Often it's not very often that somebody asks that to design a module that you need to be able to remove a certain amount of times of a module, and it needs to be easy to be done by a customer, because maybe that's something that we didn't say or we didn't stress so much, but the modularity in the end is to facilitate that customers repair their phones themselves as well. We obviously have our own repair center. So we believe that if we make it so easy that anybody can do it at home, then of course at the repair center is also much more cost effective and faster to do. But I would say that, you know, like the plastics and the connectors, that's definitely something we've learned.
Great, thank you. A question from Francis Mulaney. Very interesting approach on the hardware side. What approaches can you use to address the challenge of obsolescence due to software evolution? You touched on this with the chipsets, Miquel. Example, interesting requirements arising from OS upgrades.
Yeah, I'm not the expert, so I'm not a software developer, but definitely we actually have a whole team in our company that is called Software Longevity. So they are the ones really doing all this work. So what approaches can you do to address the challenge of obsolescence due to software evolution? So one thing that, again, I'm not an expert, but I know that we've gone the extra mile to be able to upgrade the software without what I was saying before, without this software support from the chipset manufacturer. And that is basically, that increases exponentially the amount of hours that you need to do in coding and the kind of things you need to do to test and try things that you may not be able to do so easily because you cannot look into this chipset, into that software. So I would say that's what takes most. I'm a bit careful to say this, but I think that's what takes most of their time, to be able to upgrade new Android releases in a chipset that is older. This is the case for Fairphone 2, for example, now. So Fairphone 2, we upgraded not so long ago to Android 9. And we've done by now, I think since we launched Android 2 or 3 Android upgrades, and this last one without the chipset manufacturer support.
Great. A material question from actually two participants. To Fairphone team, as before, in order to increase lifetime of your product, does it make sense to replace commodity polymers with specialty polymers? Did you perform a life cycle assessment on this?
I would say I would need some help in this question. So it's I'll tell what I know about polymers in smartphones. So very often you fall into using polycarbonate because it's a plastic that gives a very good performance for drop tests, and we know that we can use a high degree of recycled polycarbonate, but I would not know what are the other options in terms of housings for smartphones. I'm not sure if Thea knows more about this.
Yeah, I think what we focus on mostly is then also that we try to integrate post-consumer recycled materials in there, and through that decrease the impact, or also just show that it is possible to do this. So, and then we already have the recycled materials, but that's often also hard to depict in an LCA because mostly there is no real data on it because it's a pilot. So yeah, it's then hard to, let's say, to really connect it to the total impact that we decrease with that, because yeah, just due to that, let's say the standard databases are usually missing the data.
But yeah, maybe now I understand the question a bit more, but maybe one piece of data that I remember, at least from the LCA Fairphone 2. I would need to check for Fairphone 3, but the plastic parts of the device are really a small part of the overall environmental footprint at production of the device. If I'm not mistaken, the battery cover, which is the plastic part on the back of the phone, was something like 0.5% of the whole footprint of the whole device. So that's definitely like a smaller hotspot within the whole electronics part. One of the highest hotspots being, for example, the use of gold. So one thing that we've learned also is like the type of connectors that we use is very determined by because certain connectors will use more gold than other connectors, and the more gold you use, the environmental footprint, CO2 emissions goes really high.
Great, very interesting.
Just to give like the two sides, right? Like plastics or something like a metal.
Right. Okay. And I'm going to try and sneak in 2 more questions. The first one is from Karsten. Which design changes, improvements did mainly improve the recyclability from the Fairphone 2 to Fairphone 3?
I was expecting this question when I was looking at the slides, and I had to think. Do you remember, Thea?
I think it was also mainly the different materials that we use in there now, so that the recovery rate actually goes up, because because depending on which material you use combined with another material, you can only recover one of these materials. And I think that the material that we just had, let's say, higher amounts of material than in one module, which was then not connected to a material that could then not be recovered.
But Carsten, we can come back to you with a longer answer. We need to look it up.
And I'm going to try one more question with the risk of going slightly over, but I think it'll be worth it. Any plans for, and this is from Tom Orkaczynski, any plans for cell phone as a service? And selfishly, for myself, any plans for distribution in the Americas?
I second that distribution in the Americas. I'd love a Fairphone.
Yeah, thanks, guys. So I'll answer first the second one. So I need to disappoint you a little bit. We are pretty busy with our operations in Europe, and as you can imagine, a phone is something that requires a lot of like after sales. It's not like a piece of chocolate that you eat and that's it. So that limits a little bit our how much we can expand and how fast we can expand. So for now, in the years to come, we will remain in Europe, but of course, there's always talks in the office about other parts outside of Europe. And on your first question, actually, is an interesting and painful question at the same time, because we have researched this a lot. Actually, if you Google, I will find the link and send it to you. But if you Google circular phone, Fairphone, we did a couple of reports already investigating the economic, legal, and operational barriers to have what we call Fairphone as a service. It's all published, and it's a nice report to read because it goes a lot into depth. We use real numbers with business case of Fairphone. There is even a blueprint for a contract that other entrepreneurs can reuse as a basis. But unfortunately, we haven't been able to really launch it into the market yet, and that has to do with typical growing pains of an organization, among others, having access to enough financing, which is one of the challenges in the circular economy, especially for service propositions, because then if you need to keep on owning the devices that are in the market, that requires a different financing structure. But we will do it. It's not there yet, but all the data it's published already, so you can find it and read it if you are interested.
Well, thank you very much, Thea and Miquel. And Mark, I'm going to hand it back over to you to close out.
Sure. So yes, let me reiterate, thanks for all the speakers today and all of the active participation from the audience. We got lots of great questions. I know we did not get to all of them. We will collect them and do our best to answer them over the coming weeks as we work through this series of webinars. and build hopefully a larger FAQ and our final reports and try to address some of these questions. I do want to remind folks there is one more session that is already scheduled. It is on the books for Tuesday, July 27th. We will be having speakers from Adva Optical and Google Nest talking about their products and how they're supporting the circular economy. And we are also in discussions for hosting a series of fall sessions similar to this. And we'll let folks know that probably in July before the sessions on the 27th, whether we've got the logistics in place for a fall series that will be similar to this with maybe some learnings a little bit longer potentially, because I think we end up having lots of questions and it would be great to get to more of those. But with that, I would like to say thank you so much for joining us, and I hope that we'll see you again in about 6 weeks at our next session on July 27th.